Hi, I'm Rob Pickering, and this talk is called Callcenter AI for when you don't have a call center in a pandemic. It's a story about the development of a new app, and like most stories of 2020, in the Northern Hemisphere at least, it started in March this year. So the UK, end of March, start of April, just going into its first lockdown. People are being told to stay at home as much as possible, and some people are being told to shield and isolate at home. And that's causing some fairly changed communication needs in society, and two particular areas affected quite profoundly in terms of the kind of contact that they're having with their client base. So one part is new mutual aid organisations that are springing up on a neighbourhood basis to deliver social support and practical support to people who are isolating at home. And the other kind of organisation is businesses who have had to change their business model to continue to operate, or change their business model to support their community. And a good example of this that I'm quite familiar with are food service organisations who've been working in B2B hospitality supply. So they've been delivering wholesale food supplies to hotels, other parts of the hospitality industry, which is now closed down overnight. So to support their communities, they're pivoting to do home deliveries of food. So they've got chillers full of food that is going to spoil, and they're figuring out how to go from dealing with maybe 30, 40, 50 deliveries to large deliveries to wholesale customers a day, into dealing with hundreds and hundreds of small domestic customers who are calling up and placing small deliveries that they're then repackaging wholesale goods and delivering to. And then the other one is the mutual aid organisations who sprung up usually with nothing more than a WhatsApp group and maybe a little bit of infrastructure, but certainly no office-based phone lines or anything like that. But all these folks are dealing with the demographic of people that want to actually call into them. So you look at the demographic of folks shielding. Yes, you can go off and develop an app or a website, but the reality is that phone contact is still a big thing for a lot of these organisations. So how do we deal with inbound phone calls became quite a big problem. And I got involved in some of this, working on essentially lashing things together. And to meet their needs literally overnight in many cases, we ended up lashing together a couple of simple data collectors based on phone gateways to things like Dialogflow or Twilio, and then bits of code running in webhooks or fulfillment hooks, pushing data into spreadsheets. Now, this all feels very sort of wet string and blue tack, but the reality is that it was a really quick solution. It was something you could literally put together overnight. So, trying to do some fancy CRM-based thing with a specific CRM and then train people up on how to use that CRM, even if it was an open or free one, was not easy. Often people were dealing with volunteer bases of 20, 30 people that they needed to manage workload for. So we found that we could lash up something that fulfilled an AI-based agent, something like Dialogflow on the front end, and then just push the results into, for example, a shared Google Sheet really quite quickly, and have something that was up and running. Now, the hard bit about this is that someone still needs to build the agent. So, I ended up sitting in front of Dialogflow console building agents to do this stuff, and so did other people. And those tools are absolutely fantastic. If you want to build a really sophisticated, safe agent, the Dialogflow console web interface is not a bad way to do it, particularly things like the knowledge base and Callcenter AI. But for something like this, where you just need to get something up and running, and you need to scale it out, that was actually a biggest part of the workload. Collecting the data wasn't terribly hard. So I kind of got thinking, actually, can we do something better than this? Having proved the concept and having worked with organisations that found this sort of stuff tremendously useful, I was sort of, if we can build a fairly simple self-service UI on the front of it, strip back the basic agent concept into the sort of the bare essentials of an agent with a number of intents, a bit of slot filling, some confirmations so that we can gate a real finished inquiry from a speculative one, some sensible pre-filled unrecognised intents, and and then data capture into that simple shared spreadsheet. It kind of felt like that was something that you could build once at scale and roll out. And the particularly important bit was the self-service UI on the front of it. So started thinking about this and thinking about how I could do it. At almost exactly the same time, I ended up having a conversation with Dan from Founders and Coders. Now, because this is TADSummit, this is a very old picture of a group from Founders and Coders at TADHack in, I think that was 2016, might have been 2017. But if you aren't familiar with them, they're an awesome social enterprise who provide an intensive open source full stack training program that's sort of free at the point of use by folks who would otherwise struggle to get into our industry. And in my conversation with him, he was telling me that the cohort that were mid-course when lockdown was declared were not really having a great experience finding placements because the tech industry wasn't hiring into junior positions at that point in time, and the organisational chaos that lockdown and COVID was causing was really derailing things for the cohort that were just coming to the end of. They'd had to shift from on-site right at the start of the cohort to going remote really early on, and also some of the funding from their own staff was in peril because of their model where they sustain themselves through effective recruitment fees on their grads. So. That was distressing to hear because they're such a great organisation. But actually, I started hatching this plan that if I could pull Founders and Coders developers into doing some of the front end work on this scalable application, then actually I'd be providing some quite useful first employment for some of the folks, but also generating something that's kind of socially useful and met an immediate need in doing so. Of course, that still left me with a bit of a problem of finding some funding. And almost at that exact moment, Innovate UK pushed out a de minimis quick-turn funding call called Business-Led Innovation in Response to Global Disruption, where they were looking for SME-led and SME-targeted development that was aimed at having an impact on the kind of issues that COVID was causing. So I stuck an application in for that with Founders and Coders, with them as the delivery contractor and Aplisay doing some of the infrastructure work. But there were about 8,600 applications, and it was clear the funding was only really good for about 400 to 800 of those to be successful. Didn't think a lot more of it and carried on hacking spreadsheets and Dialogflow console stuff. And then we found out just before the start of June that we'd actually been successful. We got some funding to go off and build the application I envisaged. So absolutely brilliant. Thankfully, that there were a few of the Founders and Coders current cohort who were still available, and we were able to set off and start developing it, which was great. In terms of how we put it together, this was kind of the architectural overview, and like all great architectural diagrams, I kind of drew this right at the start of the project and said, yep, this is how we're going to do it. The reality of what we ended up building was something that in the end ended up being deployed on Kubernetes containers. So it's a full kind of microservices template application, and Kubernetes seemed like a great idea to be able to scale it, because remember, the objective of the thing was not just to make the front end super usable, but also that we'd be able to deliver the scale to hundreds or thousands of organisations in a self-service manner. So what we effectively ended up building was something that could be hosted in regional Kubernetes clusters. Google gave us a brilliant environment to do that in, and I'm going to talk a bit about their generosity towards Aplisay in a second. But what we effectively built was a fairly standard thing that looks like this. So at the front end, we got a non-real-time node pool that effectively housed all the stuff that is kind of generic web applications. So front-end web server serving up a React app, and that was fundamentally what the Founders and Coders team worked on. So they effectively worked on React app. The React app talks to backend service, which is application specific, and an agent management daemon. Now, the agent management backend service is sort of a separate thing, and the reason for for that is that's based on a piece of IP that we're already developing to front end various conversational AI systems in a platform independent way. And it does give us some advantages doing things like that. But what we decided to do was put all of the SME app specific stuff in this back end service and keep the agent management services in the front end. Now, what it allows us to do is to do very rapid changes to the agent specification, and those changes to the agent specification happen in our own application database. So very, very quickly when we're editing intents and entities, those can be instantaneous using optimistic updates. And then when we finish building the agent according to the rules in the application itself, only then do we push it down into a back-end system, in this case Dialogflow. So that's kind of how the front end worked. Now, the back end, the telephony back end, we landed on an architecture that put that on a separate node pool, actually, and kind of the reasons for that are resource related. There's a lot of RTP going on in on the telephony back end, and running that in a fairly dynamic node pool on auto-scaled CPU resources didn't seem like a great idea. And indeed, we had some experience with RTP stuttering and things if we didn't get a well over-resourced telephony pool, but you don't want the expense of an over-resourced pool for the whole application. So the way that the telephony piece works is that we have an asterisk container, and this is just containerized asterisk, and there are 3 bits that sit alongside that. And I have to give a big shout out to Dan Jenkins at Nimble8 who produced this. So this is his Dialogflow ARI bridge and Dialogflow RTP audio server. And what they essentially do is work with an MQTT server to do highly asynchronous bridging between Asterisk and Dialogflow, and it works great. We kind of forked off the audio server in particular to do something slightly different because it has to look up the agent that's specific to the user and do all sorts of hippie stuff there. But the ARI bridge is pretty much Dan's vanilla ARI bridge. So how it works, call comes into Asterisk. The ARI bridge is sitting on a one-line stasis dial plan. Asterisk is sitting with a one-line stasis dial plan that just tells the ARI application. When the ARI application finds out about a new call, it drops an event out to or actually several events to the MQTT server that tells the audio server that there's a new audio stream that needs serving, and then it effectively talks to Asterisk, puts up a port that listens from the media stream from Asterisk and starts talking to Dialogflow and bridging between Dialogflow's streaming intent detection and Asterisk's RTP media, feeding all of the intent recognition events back into the MQTT server. And I'll come in a second onto what we actually do with those. So in the general node pool, we have a service called the Event Reaper that sits on those MQTT messages. Now, you get loads and loads and loads of events out of streaming intent detection from Dialogflow. So you get partial transcriptions. Every time you get, for example, a digit in a phone number or partial transcription, you get an event from there. We're not actually interested in most of those for what the application does. So a big part of what Event Reaper does is just correlates events and gets them down to the important ones that we're really interested in. So a conversation started, we got a chunk of transcription, and we got a recognized event with some parameters, and pushes them down into our application database. Then from there, again, we have a non-real-time component called Google Insert that runs on multiple pods across the cluster. And all that does is sits on the database, polling using record locking for a bunch of rows that correspond to things that are events that have been detected on behalf of clients that it can put into that client's Google spreadsheet. So again, completely asynchronous. If the Google Sheets API goes away for 3 hours, nothing bad happens to the infrastructure. It carries on running, recognizing intents and doing work. When the API comes back, then there'll be a whole bunch of database rows that are stored in there, and these pods will be working overtime to transcribe those or to take those database rows out and put them into the Google Sheets API. So that's fundamentally how the application works. Maybe it's worth going and actually having a look at it now. This is what a user sees when they land on the application. They go through a Google OAuth screen because we need that for the spreadsheet access anyway. But the first thing they'll do is create a new agent. And we tend to encourage them to use names for their agents rather than boring descriptions of what they do, just because it makes the whole thing more human. First thing to do is add a greeting. So they'll add a greeting that lets callers know where they've landed, and then start naming requests. Now, requests are basically intents, but we don't use language like intent or entity because that's not something that SME trying to build an interface knows about. So we're just going to call the request book a delivery, and then they're asked to type in the kind of things that a customer might say to them when they want to fulfill that kind of request. And then within the request, obviously, folks that understand conversational interfaces, we've got entities. We don't call them that. We call them details. So they're variant things that can occur in a request or an intent. And we can either use system entities for things that we know about, like phone numbers, addresses, locations, or create new details, which are things that are specific to this organization that are, in dialog flow terms, a kind map. So, for example, what we're doing now is just creating a new detail, a new entity type for the kind of products that the customer can buy from this organization, and we're gonna build a pretend food service organization. That gives us a detailed type of product, and then we give it a column in the spreadsheet that we're going to extract that into. So we can see we've extracted in something called what. And then we type in a few more phrases. So these are a few more ways that a customer might make a request that we use for agent training. I'm not going to put too many in here because obviously it's going to be a fairly slow demo if I do. But you get the idea here. We'll just put 3 or 4 in so that we can see a range of requests and how we deal with spelling entities out in them. You can see that I'm just typing these in English now. I could have used a sort of a handlebar notation with a dollar curly bracket to spell out the entities I type them. So power user tip, we can put things in curlies there. Chose not to on here, and I'm just going to go through and I'm going to highlight the product entity, the what. In all of these, you'll notice one of those requests doesn't have have any kind of entity or slot because the customer hasn't been specific. So I'm going to say that's a required detail because we want to capture what the customer wants to buy, and I'm going to add a prompt for that. But we also need a name as well. So I'm going to create a new required detail for name. And I need a prompt for that as well. So let's say, please can I take your name? And we'll also do a where. We'll do address capture here. This is sort of infamously inaccurate for doing in conversational AI, but at the very least it'll allow us to locate, it'll allow a human being to locate who the customer is. So we're going to prompt for an address. So this entity, when we notice the customer requires a delivery, we're going to prompt for what they want, who they are, and where they are. We'll put a confirmation step in, so we'll click on yes to say yes, we want the agent to confirm. And let's fill some slots in there as well, actually. So let's read back the details. So let's read back the detail of what they want and the address that they want it sent to. And then after the customer has confirmed that intent, and I'll use the handlebar notation here, then we confirm back to them, so we read back to them so they know that we've got their request, and then we'll just do, we won't make this a terminal intent, we could have done, but we'll loop back, because in reality we might put many different kinds of request or intent, and that really is a basic agent built then. So what, 3-4 minutes, we hit the publish button. When we hit the publish button for a new agent, we get a list of all the the available phone numbers that we've got, and we can select it by area code. And we also get a prompt to link to a Google spreadsheet using the Sheets API. So this is a stage where we tell the system where we want the results of the recognitions to go to, and we just select a spreadsheet and a tab. Click Publish, and this is the first point where the system starts interacting with Dialogflow. So up to now, all of that agent building and all the validation has just been going on against our back end, and it's only really when we click Publish that it gets pushed into Dialogflow. So if you're familiar with some of the interfaces on Dialogflow and other products, there are some delays when we click load buttons for retraining and all that kind of thing, but that only happens once at the end of here. So now our agent's been pushed into Dialogflow, we've made all the connections, and we're now live. But let's place a call to the agent now and have a look at how it works.
Hello, welcome to Food Service Limited. How can I help you today?
Can I get some chicken delivered, please?
Okay, please can I take your name?
Yeah, my name is Rob Pickering.
And what address would you like us to deliver that to?
3 The Cedars.
Thank you. Please could you confirm you would like us to deliver some chicken to 3 The Cedars?
Yes, that's right.
That's great. We will be in touch with you shortly to discuss your chicken delivery. Is there anything else at all I can help you with?
No, I'm finished. Thank you.
Okay, thank you for calling.
Okay, and as you can see, what I've got now is a row that's arrived. It tells me who the agent was, what the caller number was, how long the call lasted, the intent, what they wanted to do, and if I hover over this, which is quite useful, I can get a full transcript of what they called for. So that basically is the full service area of the product from an SME point of view. It's very, very simple, very, very scalable, and can just be dropped straight onto an existing workflow. So there are a bunch of credits to people who've been absolutely instrumental in getting this application working so well. So first of all, the Founders and Coders folks. So Hannah and Ruben, 2 Founders and Coders grads who came straight off their end of their course into a remote first project and performed so well building the front end for this. Ollie, their developer in residence, who coached and mentored them superbly, as well as writing a decent chunk of the code that went into the application and doing a massive amount on the architecture, particularly the front end architecture. There are loads of open source projects that have been used in delivery of this application. I can't call every single one out, but fairly pivotal was the work that Dan Jenkins at Nimble Ape did on the Asterisk Dialogflow ARI server and Asterisk Dialogflow RTP audio server. Him putting that together, frankly, gave me the imagination to do this. So the fact that that existed back in March, April is the only reason this project actually happened, because I could pick that up and run with it. And as I say, it sort of gave me a base to have the imagination to even build this in the first place. And Asterisk, of course, Digi and Sangoma, without which I probably wouldn't even be working in this industry, but obviously that's a core part of delivering the audio flows. Couple of organisations that have helped very materially. Google gave Aplisay a bunch of cloud credits under one of their programs, thousands of pounds worth. Running big Kubernetes clusters doesn't come cheaply, and putting this together wouldn't have been possible without their largesse in getting us started up with it. And Innovate UK, who gave us the de minimis grant that paid for all of the work that Founders and Coders and some of the back-end work that we did. So without all of those folks together, none of this would have happened. In terms of playing with this going forward, I'm still figuring out how we actually roll it out. My current thinking is that the best way to get this out to the largest base is part of a larger offering, so it works really well, I think, as a bolt-on to an SME or charity telephony offering. Yeah, there's probably some path to monetization of selling it on a per seat basis or per month basis to lots of different organisations. But that's going to be an interesting challenge scaling that out. If you want to have a play with this and maybe have any ideas about how it might fit in for your organisation or offerings that you're delivering, then Robin J. Pickering on Twitter, DMs are always open, although I appreciate that's a bit of a mouthful. Email to hello@aplisay.com or www.aplisay.com. There's going to be an open beta sign up form on that website, certainly within the next couple of days. So if you do want to go and have a play with this, sign up for the beta. That'll get you access to it, and you can have a play with the whole solution. Thanks ever so much for folks that have sat through this whole presentation. Hope you've enjoyed it, and thanks very much to Alan and the whole TAD ecosystem for the support and giving me a platform to talk about this today. Thank you.